Welcome back. In this video we're going to look at solving equations containing rational expressions. We've seen how to add and subtract rational expressions, but how do we solve equations that contain them? Well, there are three main steps that we need to do. The first thing is to find the LCD and then multiply both sides of the equation by the LCD. This will eliminate all your denominators. The second step is to simplify the equation now and then solve for the variable. And the third step is to check the solution. Sometimes you come up with solutions that actually are not solutions, and we'll see as we go along some examples. So you must always check your solution when you're solving rational expression equations. Let's take a few examples. Here we're asked to solve the equation x over 2 plus 8 over 3 is 1/6. So the first thing we have to figure out is what is the LCD. If we look closely at this, we'll find the LCD of 2, 3, and 6 is going to be 6. Right? Because 2 will divide into 6, and 3 will divide into 6, and 6 will also divide into 6. So the LCD is 6. So the idea, the first step, is to multiply the entire equation, left and right, by 6. 6 times x over 2 plus 6 times 8 over 3 equals 6 times 1 over 6. So we've multiplied everything by 6. And notice that the 6 will cancel with things below. So in other words, 6 divided by 2 gives me 3x, and 6 over 3, that will cancel to 2, and 6 over 6 will cancel to 1. So what we end up with is 3x, and then we have this will cancel to 2, so 2 times 8 is 16, and these 6's will cancel to give me 1. So 3x plus 16 equals 1, and then we need to solve this for x, first by subtracting 16 both sides. So if we subtract 16 from both sides, we get 3x equal to negative 15, and then divide both sides by the 3 next to the x to get x equal to negative 5. So my solution is x equals to negative 5. Now we should always check this, and so let's go ahead and check this. Our solution is negative 5, and we're going to check negative 5 in our equation to see if it actually satisfies the equation. So we plug in negative 5 for x, and our equation was x over 2 plus 8 over 3 equals 1/6. So is negative 5 over 2 plus 8/3 equals to 1/6. So we have to add these fractions, and we do that getting a common denominator of 6 and making these equivalent fractions. In other words, we multiply this one by 3 over 3 and this one by 2 over 2, and so what we end up with is negative 15 over 6, negative 5 times 3 is negative 15 over 6 plus 16 over 6, 8 times 2 is 16. Is that equal to 1/6? And we see yes, that is. So this checks out. So this is the solution. Let's take another example. Okay, here we're asked to solve 3 minus 6 over x equals x plus 8. We want to find what value of x satisfies this equation. One thing to note though, before we go on, is what can x not be? You remember we cannot divide by 0. So if x was 0, we would be dividing by 0 here. So x cannot be 0. So that's something you want to make a note of as you go through it before you even solve the equation. X cannot be 0. So the first step to solving the equation is finding the LCD. The LCD is very simple in this case. It's x. It's the only denominator we have, x. And so we multiply through everything by x. And why do we do that? In this term here, the x will cancel with the x below, and we'll have no more denominator. So we will eliminate the denominator. So let's rewrite our equation. 3x, 3 times x, minus 6, because these x's cancel here, equals x squared, x times x, plus 8x. Now, we actually have a quadratic equation. Quadratic means that this is a squared, the highest power is the square on the x. To solve a quadratic equation, we have to move everything to one side and leave 0 on the other side. In other words, we're going to have to subtract 3x on both sides and add 6 to both sides to get 0 equals x squared plus 5x, because 8x minus 3x will give me 5x, and then we add 6 to both sides, so that's going to give me a positive 6 on the right side. So now we have a quadratic equation we can solve this by factoring. If we factor x squared plus 5x plus 6, we get x plus 2 times x plus 3 will give us that x squared plus 5x plus 6. And then we set each of these factors equal to 0. So we'll have x plus 2 equal to 0 and x plus 3 equal to 0, which means x is either equal to negative 2 or x is equal to negative 3. So both of these are our solutions. However, we know we don't have this restriction here, so neither of these is 0. But we still should check these solutions to see if they satisfy our original equation. So let's check x equals negative 2 and x equals negative 3 in our equation. So we check our solutions, x equals negative 2 and x equals negative 3. Let's check x equals negative 2. Well, if I plug negative 2 in here for x, we get 3 minus 6 over negative 2, and then equal negative 2 plus 8. Are they equal? Well, this is going to end up being 3 plus 3, and this is going to end up equal negative 2 plus 8 is 6. 3 plus 3 is 6. So yes, that's the solution. That checks out. So x equals negative 2. Similarly, with x equals negative 3, we plug it into our equation. We get 3 minus 6 divided by negative 3 equals negative 3 plus 8. And the left side becomes 3 plus 2. And the right side becomes negative 3 plus 8. That's 5. The left side's 5. It checks out. So x equals negative 3 is also a solution to this equation.